Jai Hind students, myself Shiva Tyagi from Department of Computer Science and Engineering. Today we'll be discussing a very important topic in the subject computer system security, and the name of that particular topic is digital signature. So these are the contents that I'll be covering throughout this particular presentation. Initially, I'll tell you what actually digital signature is. Now, the second question arises that why there is a need for digital signature. That is again a very important issue, that if you are using any digital signature, what is basically the necessity of using this digital signature? Then again comes the question that what are the basic requirements of this digital signature, right? Why there is a need for this digital signature? What are the basic things or the resources that we generally use for creating a particular type of digital signature? Then how the technology works behind it? What are the different approaches of digital signature? What is basically the purpose of this digital signature? As in our day-to-day life, we generally use this digital signature. So what is basically the main purpose of digital signature? That of course I will be discussing. Then comes the challenges and the opportunities in the field of this digital signature. Then the applications, drawbacks, and lastly I will conclude about the digital signature. So, introduction part. See, the authenticity of many legal, financial and other document is basically determined by the presence or absence of any authorized handwritten signatures. It's very easy to understand that if we have to authenticate any type of legal document, right, that legal document or any type of document, a normal type of document also we can consider out, that is basically determined if and only if we will be able to authenticate that from what particular source that particular document is coming. So it is something which is going to determine the presence or absence of the authorized handwritten signature, right? If there is a particular type of document and that particular document is basically a signed document and a handwritten document, what it is basically guarantee? It is simply guaranteeing that that particular document is a authorized document, or that is a document which is coming actually from some authorized type of source. So there are number of methods, there are various methods that have been devised to solve this particular problem, but again the use of this digital signature is the best solution among them. So the main issues that can generally be pointed out with the help of this digital signature is basically the authentication, is basically the integrity of the data and the non-repudiation, right? So that means we can make sure that if the data or if the document that we are getting, if it is digitally signed, so it is something which is going to prove and which is going to make sure the authenticity from what particular source we are actually getting this data. So we need to authenticate the source also. We need to make sure that the data during or the document during the transmission basically is not tampered, is not changed by an unwanted person, or simply we can say by the hacker whose main intention is to fetch the particular piece of information. Now, what is this digital signature? This is nothing but an attachment to the piece of electronic information, right? It is basically a type of attachment to any piece of electronic information or the data that we are sending, which represents the content of the document and again the identity of the originator of that particular document uniquely. Okay, so it is basically the piece or an attachment which is going as a type of separate document with that electronic document, which is simply representing that what is actually the content of that particular message, and again which is make sure with the help of the integrity that of course I'll be discussing in the forthcoming slide, and the identity of the originator, from what particular source we will be getting this particular document. That is important, that is must. So we need to make sure about the authenticity, that from what particular source we are getting this particular document. Now, what is digital signature? Hash function of a message when encrypted with the private key of a person is the digital signature on that particular type of e-document, right? So that means in a very simple words, we can say that if there is a particular sender, that particular sender is going to create a hash function using any of the other hash algorithm, or hash function is basically created, and that particular hash value, it is encrypted with the private key of that particular person, which is only known to the sender, whosoever is sending that particular document. That is not a public key, that is basically the private key. So that particular hash value, it is encrypted with the private key of the sender, that is only known with the sender, is basically the digital signature on that particular piece of e-document. So digital signature of a person therefore varies from document to document. So that means we can say that for each and every document it will definitely be different. It ensures the authenticity of each particular word of that particular document. As I told you, that it is something which is going to guarantee the authenticity, that from what particular source we will be getting this particular document or the message. So it is guaranteeing the authenticity of each particular word in that individual document. Now, as the public key of the signer is known, anybody can verify the message and the digital signature. Now, the question comes that why do we need a digital signature? It simply provides the authenticity, the integrity and the non-repudiation to any electronic document, right? The basic aim of using the digital signature is that it is something which is going to provide the authenticity, that from what particular source we are getting this document, it is going to authenticate it, right? If the data is basically, a document is basically digitally signed, so we need not have to worry that it is like the data which is coming from some unauthentic source, because it is the general issues that we generally use to encounter in computer system security, that the document that we are getting, we need to make sure that that particular document is something which is coming from some authentic source. Again, if we discuss about integrity of the data, it is also important that we need to maintain the integrity. That means during the transmission, the particular document is not tampered, is not actually changed by some unwanted person. As it is data, whatsoever has been sent by the sender, the same data has been received by the receiver. So it is something which is going to make sure the integrity of the data. And again, the non-repudiation. What is this non-repudiation? After sending a particular message, the sender cannot deny that this is the message that has been sent by me. Right? Later on, there might be a case that after sending a particular piece of information, the sender may deny that this is not the data that I have sent. So if we are going to ensure the non-repudiation, it is something which is going to guarantee that the sender, after sending that particular information, later on cannot deny that this is the data that has been sent by me. This is something which is going to ensure the non-repudiation. Now, to use internet as the safe and the secure medium for banking, e-commerce and e-governance with security of servers. Right, for our day-to-day life, we can say that we are using the internet. Okay, so how trustworthy it is? Okay, we are using any type of secure medium for online type of transactions, for banking, for e-commerce, for doing different type of shoppings, e-governance. So we should be having some or the other mechanism based on which we will be able to trust a particular document that we are getting through the medium which is actually an internet. And digital signature is the one which will help you assure that. So it is must that we need to guarantee, we need to make sure the authenticity, we need to make sure the integrity, we need to make sure that the data has not been changed, not been altered during the transmission. Now, what is actually authenticity? Why there is a need for authenticity? Although messages may often include information about entity sending the message, that information may not be accurate, right? There may be the cases that the message that you are sending, they're going to include the information that from what particular entity we are getting that information. But how we can be very much sure that that particular information that you are getting is perfect, is okay, is correct, right? So digital signature can be used to authenticate the source of the message. That means the message, the source from which we are getting that particular document need to be properly authenticated, and that we can actually achieve with the help of this digital signature. So when ownership of the digital signature, the secret key is bound to the specific user. As I told you earlier also, that secret key or the private key with the help of which the encryption is basically done at your sender end is only known to the specific user. Then a valid signature shows the message was sent by that individual user. So we need not have to worry that particular message is coming from some unauthentic source. So this authenticity is basically assuring that. The importance of high confidence in sender authenticity is especially obvious in the financial context. See, when we are doing any sort of monetary transactions, it is must that before doing that particular type of transactions, we need to make sure that from a particular source, if we are getting it, is that source the accurate source, or there is some forgery type of issues which is going on behind it. Okay, so for example, suppose a bank branch office sends the instruction to any type of central office requesting a change in the balance of the account, right? It is a very simple example that we can say that there is any particular type of bank branch, the main head office you can say, and that particular main branch is simply sending some sort of instructions to the central office. What instructions that particular branch is sending? Is simply requesting to change in the balance of a particular piece of account. Now, the important questions which arise here is that if the central office which is getting the information regarding the change in the balance from the branch office, it is not convinced, that particular central office is not convinced that such a message is truly sent from the authorized source, acting on such a request could be a grave mistake, right? It is something, as you know, that it is directly related with the type of monetary transactions, and if that particular central repository or that central bank is actually not sure that from what particular entity that particular message is coming, it is truly sent from that authorized source, and if they are doing any sort of transactions and all, it is definitely a biggest type of mistake. And so that is something based on which we will be able to make sure regarding the authenticity with the help of that digital signature, that if the data is basically digitally signed, we need not have to worry about the authenticity, that from what particular source we are getting this individual message. Now, next important terms that comes here is basically the integrity of the message, right? With the help of this authentication, we actually make sure that the data or the document which is digitally signed is basically coming from the authentic source. Now, the important thing that generally occurs during the transmission, that whatever data has been communicated, is that data changed during the transmission, right? There can be any unwanted type of source which basically hacks the data and make any sort of amendment, make any sort of change in the data that has been sent by the sender. So we can say that in many scenarios, the sender and the receiver of a message may have a need for the confidence that the message has not been altered during the transmission. That is an important thing, right? If you are sending the message and that particular message has been altered during the transmission, then what is the meaning? I mean, how will be able to achieve the security of that particular piece of information? So it is only assured with the help of the integrity, that during the transmission, the data or the document has not been altered, has not been changed. So although encryption hides the content of the message, right, we will be using some or the other coding mechanism, we will be able to encrypt the particular type of data, with the help of which we will be able to convert the plain text to the cipher text. But again, the question comes that it may be possible to change an encrypted message even without understanding it. It is but obvious that whosoever is having the key will be able to decrypt it. But there has been cases, there might be a possibility that even that particular encrypted message or that coded message has been changed without even understanding that particular message. So some encryption algorithm which are known as non-malleable ones prevent this, but others, do not. So however, if the message is digitally signed, any change in the message will invalidate the signature which is coming from the sender side along with that particular message, right? During the transmission, if the data, if the document is basically changed, it is something based on which we can say that if the data is of the document is basically changed, any change in that particular document will simply invalidate the signature, which is actually done at the receiver side by verifying that particular signature. Furthermore, we can say that there is no efficient way to modify a message and its signature to produce a new message with the valid signature, because this is still considered to be computationally infeasible by most cryptographic hash functions. So it is important that we need to maintain the integrity of the data. And in simple words, I can say that during the transmission, the document, the message has not been altered, which is a very common issues that we generally encounter when we are talking in terms of different type of attacks, different type of issues during the transmission of a particular piece of information. So digital signature is something which is simply going to guarantee, which is simply going to make sure along with the authentication of the sender, the integrity of the data as well, that during the transmission the data has not been altered, the data has not been changed, and we are actually receiving the same piece of information, the same piece of message that has been sent by the sender. Now, what are the basic requirements for this digital signature? The next question is that what are the different requirements for digital signature? First is of course the private key. Now, what is this private key? The private key is one which is accessible only to the signer of that particular message. It is used to generate the digital signature which is then attached with that particular message. Right? So it is only accessible to the signer. Nobody else other than the signer will be able to access this private key. Then second is the public key. The public key is made available to all those who receive the signed message from the sender. Right? So it is something which is available to all those who is going to receive a signed message from the sender. It is used for the verification of the received message. That means data at the receiver end need to be properly verified. The digital signature need to be properly verified. So with the help of this public key, it is used for the verification of that particular received message, the message which is received from the sender. So the basic requirement is that at your sender side, the data need to be encrypted only with the private key of the sender, of the signer, and at the receiver end it will be decrypted by the public key whosoever receive that particular type of signed message again from the sender. So the basic requirement is that which will be having the private key as well as the public key. Now, digital signature certificate, a subscriber of the private key and the public key pair. So there is basically a type of pairing basically takes place, right? Be encrypting it with the help of private key, and again at the receiver will be able to decrypt with the help of the public key. So there is basically a type of key pair which is generally generated. A subscriber of private key and public key makes the public key available to all those who are intended to receive that particular message from the subscriber. But in any case of any dispute between two sides, there must be some entity with the receiver which will allow the receiver of the message to prove that the message was indeed sent by the subscriber of that particular type of key pair, and for that is actually the reason that we use this digital certificate. So this is done with the help of digital signature certificate. Now, how the technology actually works, right? as we can see that there is a particular user and there is a message which that particular user or that particular sender is basically sending, and using a particular type of hash function which is going to generate a message digest with the help of a particular type of hash algorithm. A hash code will be generated, a digest will be generated, and that is basically encrypted with the private key, right? And this is basically the private key of the signer, of the sender. In this particular case, we are simply referring it as A. So that particular digest, that particular message digest is encrypted only with the private key of the signer, with the private key of the sender. That means the A, using any or the hash algorithm which is generally applied to a particular type of message that is going to send, will be getting some sort of message digest in the form of some hash code, and that is basically encrypted with the help of the private key, and this is the private key of the signer. Signer is basically the sender, which is a user A in this particular case. Now that particular message and that hash code is basically appended, and then the message will be transmitted to the receiver. So at this particular end, again the process of verification takes place, right? At that particular end, at the receiver end, the process of verification of that digital signature generally takes place. So the use of digital signature usually involves two processes, one performed by the sender and another one is the one which is performed at the receiver. That means it's not a single process in which we can say that the whole process takes place at one end. It involves basically two processes. One is performed at the signer and the other is performed at the receiver end. Now, digital signature creation uses the hash result which is derived from and unique to both the signed message and the given private key, as we have seen in the previous figure, right? A hash code, a hash or the message digest basically will be produced, and that is basically something which is unique to both the signed message and again the private key. So for the hash result to be secure, there must be only a negligible possibility that the digital signature could be created by the combination of any other message or the private key. The possibility of creating that particular secure message and all, the possibility is actually very less or negligible. You can say that you are going to produce, that you will be going to generate the same type of digital signature simply by the combination of any particular sort of message or the private key. So this is the creation process basically takes place at your like the sender side, the signer side, and again there is one process which is basically done at the receiver side, that is what is called as digital signature verification, right? Earlier we have done the creation, now at the receiver side we'll be able to do the verification. Now what is this? This is the process of checking the digital signature by reference to the original message and the given public key, right? Corresponding to the particular public key, be able to decrypt the message that is basically coming from the signer side, thereby determining whether the digital signature was created for that same message using the private key which is used by the sender, and that corresponds to the reference public key. Right? As I told you that there are basically two keys which are basically used in for the purpose of digital signature. One is the private and the another one is the public. Private is the one which is basically used by the signer, you can say. Public is the one which is used by the to whomsoever we are sending that particular type of digital document. So this verification is the process which generally takes at the receiver end, which generally takes place at the whosoever person who is receiving this particular type of document, and will be able to generate the particular message by decrypting it with the public key corresponding to that particular message. Will be able to determine that that particular signature was created for that same message using the private key which correspond to the referenced public key. Now, how it is basically generated, as I told you, there is a particular type of message right? A type of hash algorithm will be applied on that particular message, with the help of which we will be able to get a type of hash code, which we are calling it as a type of message digest. Then again, with the private key of the signer, we'll be able to encrypt that particular type of message. So this is the process which generally takes place at the signer end. Second is the process which takes place at the verification or at the receiver end, that once receiving that message, applying the hash algorithm, with the help of which you'll be able to get that particular message digest hash code, and then again with the public key that will be decrypted, and again if it is yes, then signature is verified. If it is no, that means if it is not matching, then we can say that signature verification basically fails. So challenges and opportunities: as institutional cost, institutional overhead again is quite high. The cost of establishing and utilizing certification authorities, repository and other services, as well as assuring quality performance of their functions. So there is institutional overhead which generally occurs. Then again, subscriber and relying party cost. A digital signature will require software and will probably have to pay a certification authority. They have to pay to a certification authority. So some price issues a particular type of certificate. Hardware to secure the subscriber private key may again be advisable. So these are different challenges and opportunities. Next comes is the applications. Of course, in electronic mails, data storage, electronic fund transfer, software distribution, e-governance applications. Some drawbacks are also there. The private key must be kept in a secure manner. That is a most important thing. The process of generation and verification of digital signature requires considerable amount of time, right? Enough amount of time is basically required for the purpose of generating and verification of that particular digital signature, which you can also say as a type of drawback. For using the digital signature, the user has to obtain private and public key. This receiver has to obtain the digital signature certificate also. So thank you students. I hope you have understood this particular topic, which is very, very important in computer system security. Thank you so much. Thank you.